Hello friends, now we are going to discuss another technique, algorithm technique called decrease and conquer. Remember that we have discussed that brute force technique, we have discussed divide and conquer strategy, and now we are going to discuss third technique, that is called decrease and conquer. So name itself is decrease. It means what? Problem size, original problem size we are going to decrease, right? And finally we are going to solve that decreased part of the problems, and later on we will be getting the final solutions for original problems. So you can see that, as for example, when you are dealing with the factorial, and we have discussed already in this previous class, that when you are finding the factorial, it means what? We are decreasing factorial of n minus 1 into n, means n into n minus 1. So earlier, say we have fact of n can be written as n into fact of n minus 1. What basically you are doing? Here it was size n, we have decreased by 1, called size n minus 1, decreased by 1. Similarly, in a Fibonacci series, what will happen next iteration? Next iteration shall be n minus 1 into fact of n minus 2. What will happen? Decrease by 1. So problem size will decrease by 1, that is called decrease by constant. Similarly, in a Fibonacci series also we are decreasing by 1 by adding previous two values, we are getting the current values, right? So let us see that introductions of decrease and conquer, then we will discuss insertion sort, and we have graph searching algorithms. Under this we are going to discuss BFS and DFS algorithms, and last is topological sorting order and its complexity. Topological sorting order and its complexity. So first, introductions. As I said you that decrease and conquer is another algorithm technique in which we are just decreasing the problem size, and thereafter we are going to find the solutions. Here we have three major variations. We have decrease by constant factor, and variable size decrease. Okay. When you are talking about decrease by constant, right, it means what? Problem size you are going to decrease by 1. And as for example, we are going to discuss insertion sort. Like problem size is n, then you are going to decrease by n minus 1, hence you are going to find the solutions. So how it looks like? We have a problem size of n, we have just decreased by 1. Here we have problem size of n minus 1, right? And we are going to find out the solutions, right? Solution to the given problem of size n minus 1. Solution to original problem. Solutions to original problem. So we are getting the size n minus 1. So decrease by constant. Example is insertion sort is one of the examples, right? We have DFS, we have BFS concept. These all are decreased by 1. When DFS, depth first search, breadth first search, right? These all are decreased by constant. Now, what is a decrease by constant factor? Decrease by constant factor means what? Where we are going to decrease by problem size by half in each and every iterations. So say, if you have problem size a to the power n, can we perform the task like a to the power n by 2. Next time decrease by 1. And how you are going to get it? Our original problem is n by 2 square. Right? So here what happened? We are decreasing the problem size by n by 2. Each and every iterations problem size is decreased by just half. Okay. So here if you have problem size, say problem size of n, then we are talking about problem size of n by 2, problem size of n by 2, and we are going to find out solutions to n by 2 problem size, and here we'll get original solutions, right? Original solutions, right? Example is any exponential functions, even if you are having a power n, right? A power n, if you are going to multiply or divide, like next time it will be a to the power n by 2, next it will be a to the power n by 4, right? And to adjust that, we can have a multiplicative factor. So if n is even number, if n is even number, there is no problem, we can write a to the power n by 2 whole square. If n is odd number, if n is odd number, then we have n minus 1 divided by 2 whole square into a. So say it is 9, 9 minus 1 divided by 2 is 4, 4 into 2, 8 into 1, right, like this. Okay, so it is for odd number. So we have basically all the problem based on the decrease by constant in your syllabus, right? Last is variable size decrease. Variable size decrease is when you are going to decrease the problem size in each and every iterations differently. Say as per example, we have GCD of 14, say it is 10. Next time what is the problem size? We are getting GCD of 10 and 14 mod 10. 14 mod 10, it becomes GCD of 10 comma 4. So see your problem size is varying, right? Next iterations will be GCD of 4 comma 10 mod 2, 10 mod 2, 10 mod 4, sorry, 10 mod 4, it is GCD of 4 comma 2. Hence we are getting GCD of 2 comma 0. Hence GCD of, we can say that 14 comma 10 is equal to 2, right? Because another part is 0, hence GCD is 2. So like this comes under variable size decrease. Okay, so remember that, friend, we have 3 types of decrease and conquer strategy. One is decrease by constant. Most of the problems you are going to discuss under that. Decrease by constant factor when you are dealing with exponential problems, a to the power n, b to the power n, 2 to the power n kind of things. And last is variable size decrease. Let us see that what is insertion sort. Remember that as we have discussed that selection sort, you are knowing bubble sort algorithms, merge sort algorithms, quick sort algorithms. Those all are the sorting technique. Means list of the elements we are having it, we are applying the algorithms and sort it in increasing order, right? Or you can say that non-decreasing order, right? Or you can even go for decreasing order, depends. But we are going to sort the elements. Here name itself is insertion, insert, right? How you are going to perform the task? We will compare the elements and we are going to place it at their own actual positions. On their actual positions. It means what? We are going to find that particular element is fit at which particular place. That positions we are going to insert. And rest of the element, what will happen? Rest of the element to be shifted right hand side. Remember that array, in arrays, all our elements are stored in each and every index without break. So if you are going to insert in between, It means what? Rest all the element must be shifted towards right. Otherwise, it will be case of override when old data will replaced by new data. To avoid that, we are going to shift all the elements towards right. So just keep it in your mind. So let us see that we are going to discuss example, algorithm programs and its time complexity. So how exactly we are going to do it here is, how exactly we are going to discuss here is, say here we have 10, 5, 8, 2, 6, 3. Okay. Number of element is 6. R index 0, 1, 2, 3, 4, 5. Done. Look, we are going to compare this and this. Compare this and this. First element, second element. We can find that 5 is lesser than 10. So definitely 5 should be not in right hand side. 5 should be in the left hand side. So this 10, since 10 is greater than 5, right, 10 will go to the place of 5. Right. Now we compare it. We will check that, do you have any other elements previous to this? No. Hence, we are going to store these values, right, at place of, look, this we are going to take as a j value. J is a 0, 0 minus 1 is minus 1. We don't have any elements, hence minus 1 plus 1 is 0. We are going to store 5. First iterations. Okay. Now we are going and increasing the values. We came here. All of you please focus. Now we are going to compare, right, 10 and 8. Is 10 is greater than 8? Yes. So 10 will take the position of 8 index, means 2 index. 10 is came. Now j is decreases. J was here, j decreases, j came to here. Now 5 and 8 you are going to compare. Right? 5 and 8. Which is greater? 8 is greater. It means 8 must be inserted between 5 and 10. 8 must be entered between 5 and 10. But j pointer we have already decreased. Hence, we are going to add j plus 1 and place this new element. So j plus 1, 0 plus 1 is 1. At the place of 1, we are writing 8 and 5 will be as it is. So what happened here, friends? 8 inserted between 5 and 10. Hence it is called insertion sort. Let us see that. If you have not understand, then you can concentrate on next iterations. That will help you much. Now we have next element is 2. This is the key element. Say it is a key element. And j element will start from here. Okay. Compare this. 2 and 10. Which is greater? 10 is greater. 10 should go right hand side. Means at the place of j, j plus 1. J is 2. 2 plus 1. 3. A of j plus 1. We have stored 10. Next, we are going to compare 2 and 8. J decreases, 2 and 8. Which is greater? 8 is greater. 8 you are going to put it in the j plus 1 positions. 8. Right? So, what is logic? Logic is a plus j plus 1 is equal to a of j until condition fail. Now, we are going to compare 5 and 2. 5 and 2, 5 is greater. Hence, here is j, j plus 1, 0 plus 1 is 1, 5 is stored here. Right? So, we are assigning these values and we are decreasing that j values. So, this will do again and again. Now, j decreases. Where is j? J came to 0 minus 1 is minus 1 and minus 1 index is not there. So, these things we are going to perform the task only when j is greater than equal to 0. J is greater than equal to 0, but j is minus 1. Hence, it is over. That function will stop. It will come out and increase the values minus 1 plus 1. Then, if your cursor will come out from this, then we are going to write a of j plus 1 is equal to key element. So, a plus j plus 1 minus 1 plus 1 is 0. A of 0 we are going to put key element on. What is key element? 2. It has been done. So, let us see that next iterations. What is next is 6. right? And just I wanted to correlate with your code. Let us see that. We have 0 to n minus 1 index. As examples we have taken all elements we have read it, and output will be in non-decreasing order called increasing order. And I pointer we started with 1, I less than equal to n minus 1, I plus plus, while k is next element, right? And j is I minus 1, that is why you are decreasing the pointer, I minus 1, while j is greater than equal to 0, and if a of j is greater than key element, a of j plus 1 is equal to a of j, j is equal to j minus 1, decrease the pointer of j, and if it is fail, then what happened? What we did it? A plus j plus 1 is equal to key. So this one you are going to repeat it. So let us see that. Now I am going to correlate with that. So here this is the I positions, new I positions. Focus on both. I in this point, I is 4. I is 4, right? I is 4. Key is equal to A of I. So key is equal to A of I, A of I, A of 4. A of 4. That is what? It is 6. So key is 6 now. J is equal to I minus 1. So initial J value is I minus 1. 4 minus 1 is 3. So here is I. This is the key element. And here is 4 minus 1 is 3. It will start from 3. Now let us concentrate. While j is greater than equal to 0, is 3 is greater than equal to 0? Yes. And a of j is greater than key. That you need to check. A of j is greater than key. What is key? Key is 6. 10 is greater than 6? Yes. 10 is greater than 6. Condition is true. J is greater than 0. J is greater than equal to 0. J is 3. And 10 is greater than 6. Condition is true. If condition is true, then what are you going to do? A plus j plus 1 is equal to A of j. J is 3. A of 3 plus 1 is equal to A of 3. So A of 4, right? A of 4 is equal to A of 3. And what is the value of A of 3, friend? A of 3 is 10. A of 3 is 10. So this value is 10. So what we did? This 10, it came A of j plus 1 here. Now, based on our algorithms, j is decreased by 1. So, j was 3. Now, j is equal to 3 minus 1 is 2. Again, go and check. Is 2 is greater than equal to 0? Yes, 2 is greater than equal to 0. Right? And A of j is greater than key. That we need to check. This is the new j values. J decreases. It is 2. Is 8 is greater than 6? Yes. J is greater than equal to 0? Yes. So here j is greater than 0 and 8 is greater than 6. It is true case. If it is true, then A of j plus 1, 2 plus 1 is 3. You put it A of j. So here you are going to put 8. 8. And again j will decrease. Let us see that. Let us see that in code. We have already checked that 2 is greater than equal to 0. A of j, 8 is greater than 6. A of j plus 1. We have already added that A of 3 is equal to 8. J is equal to 2 minus 1 is 1. Again, we have to go and check that values. A of j 5. Key element is 6. Is 5 is greater than 6? No. So here j is greater than equal to 0 and 5 is greater than 6? No. It is false. This is true. And operator, finally it will give you false. So it is false. It means 6 has to insert between 5 and 8. 6 has to insert between 5 and 8. So let us see that. Once this condition is fail, right, this is true, this is false, it will come out, and what we are going to write? A of j plus 1 is equal to key. A of j plus 1 is equal to key. So what is that? J is 1, 1 plus 1 is 2, A of 2 is equal to 6. Here you have kept 6. Right? The rest of the element will be as it is. So you have 2, 5, 6, 8, 10, 3. So next is I increases by 4 to 5. Based on this example, I increases, again I will go to the next values. So in this particular case, I is 5, right? Key is equal to A of 5, that is A of 5, that is 3, so you can write it 3. And j is equal to I minus 1 is 5 minus 1 is equal to 4, right? Now let us see that if j is greater than equal to 0, yes, j is greater than equal to 0, yes, 4 is greater than equal to 0, and A of j is greater than key. A of j, let us see that, what is, this is I positions, this is j position. A of j is 10 greater than 3, yes, then 10 has to go to that third place, so 10 has to come here, right? Similarly 8 and 3, 8 is greater, 8 has to come at this place. 6 and 3, 6 is greater, 6 has to come at this place. 5 and 3, 5 is greater, 5 has to come at this place. 2 and 3, since 3 is greater, it has to insert between 2 and 5, hence j plus 1, here it will come and insert 3, and 2 will be as it is. So if you see that this equations is in, so these values are in increasing order, hence this is called insertion sort. So after doing this, remember that this A plus j plus 1 is equal to key is out of this while loop, so we have to do again and again and perform the task. Here one more things, here array index start from 0, so you take I values from the next element called I is equal to 1. We are not going to take I is equal to 0 because you are not going to compare the same element with the same elements. So give I index start with 1, while j will start from 0, j is equal to I minus 1, and this is called standard insertion sort. About time complexity, friend, if you are looking for the time complexity, you can see that it is a nested for loop. Here we have for loop, here we have while loop. So what is the basic concepts of discussing the time complexity is, we have to focus on, right, what is the input range, okay, and how many number of times basic operation is repeating. So this is the basic operations, right? So assignment operations, we are going to assign the values again and again, right? How many number of times? So that is working based on the for loop. For each and every values of for loop, while loop is working. For each and every value of for loop, while loop is working. For that reason, we are going to write the for loop as T of n is equal to summation of I is equal to 1 to n minus 1. You can see that in a code, I is equal to 1 to n minus 1 we did it, right? Next, focus on while loop. While we can see that if you are there at the last positions, if you see in this particular example, if you are there in the last positions, then in the worst case what will happen, maybe we will compare till these positions, means till 0 to n, right? So if I is the last positions, j will start from here, and what is j? J is n minus 2 positions, right? And will go till 0, yes or no? 0 to n minus 2, yes. So we are going to discuss that J loop, J will start from 0 to n minus 2, one less positions, right? And we have 1 is for basic operations. If you are going to solve this, how are you going to do that? First, inner loop I is equal to 1 to n minus 1, upper limit minus lower limit plus 1. So basically we are going to get it I is equal to 1, n minus 1, we are getting n minus 1. If you solve this, minus 2 plus 1 is minus 1, n minus 1. Now look, this n minus 1 is constant, it is independent of i's, so we can take this n minus 1 outside and we can have this I is equal to 1 to n minus 1 and here we have 1. Can we simplify further? Yes, we have n minus 1, upper limit n minus 1, minus lower limit minus 1 and plus 1. This 1 and 1 got cancelled. So we are getting n minus 1. So n minus 1 whole square. Hence it is n square minus 2n plus 1. So this is linear part, this is quadratic part. So what will be the time complexity, friend? T of n is theta of n square. Time complexity of insertion sort is theta of n square. Now question is, this is the worst case scenarios when we are dealing with the worst case theta of n square. But there is a chance where element is already in increasing order. Okay. So we got that worst case of insertion sort complexity T of n is equal to theta of n square. That we have already computed. Now think when elements are in increasing order, say it is 5, 10, 15, 20, 25 or say it is 30. 0, 1, 2, 3, 4, 5. So number of element is 6. Now here is I, here is j, right? Is j is greater than or equal to 0? Yes. Is 10 is, no, is 5 is greater than 10? No. If 5 is not greater than 10, then what will happen? We are not going to perform this task. All of you please concentrate. If 5 is not greater than 10, is false, we are not going to do this part. If you are not going to do this part, what will happen? Again we need to go and increase the I, right? Go and increase the I. Now I is here, j is here, right? Is 10 is greater than 15? No. I increases, j is here. Is 20 is greater, no, 15 is greater than 20? No. I increases here, j start from here. Is 20 is greater than 25? No. I is here, j is here. Is 25 is greater than 30? No. So basically what happened, only we are doing one comparisons under for loop, single for loop. In that case what will happen, friend? I start from 1, I gone till n minus 1 and only single comparisons we have done, that is called a of I, a of j is greater than a of I. We are doing again and again. In that case, what is the time complexity? N minus 1 minus 1 plus 1 cancel, it is n minus 1 time. So time complexity will be T of n is equal to theta of n in a best case. When it is best case, element is in sorted order. Best case, when we get theta of n, when elements are in sorted order. Elements are in sorted order. That input itself is in sorted order. That is called best case. So worst case will be theta of n square. Best case will be theta of n in case of insertion sort. Thank you. Thank you very much.